Recording started. Hello, everybody. Welcome to lecture. Today is Monday, week 2. If you weren't here last week on Wednesday, don't worry, you didn't miss too much. It was like just getting Python set up on people's computers. Nothing crazy. You can just watch the YouTube video to like at 1.5 or 2 times speed, get all caught up. Just as a reintroduction for people that weren't here last time that don't know who I am. My name is James. These are my clones. I'm the head instructor for this class. We have 5 instructors total. There's me. There's Emily Ma. Emily, say hi really quick.
Hello.
Awesome. There's Raphael.
Hello.
There's Isla.
Hi.
And then there is Megan. Where's Megan? There she is.
Hello.
And then we have Annie as an intern. Say hello.
Hello.
And then we have Claire as an intern.
Greetings.
And we have Maham as an intern as well. So instructors are like the full teachers of this course. It's like having 5 professors, except we're not professors, so we had to overcompensate. And then we have 3 interns to help out. They're like GSIs, except they're not GSIs, they're undergrads, and they're people that took this class last semester. And they're here as kind of your go-to to learn, or to like you're helping them learn how to teach this class, and they're helping you learn how to learn Python. So it's like a positive feedback loop, all good vibes around here. We're all here to help you. Instructors, we teach most of the lectures. We created your homework assignments, and we help out. Interns are like meant to come to office hours and help you in any way you need, and a whole bunch of other stuff. Everything explained in the last video, so I'm not going to talk about it too much. I just want to say thank you everybody who showed up. 40 people today. That's like a solid 10 more than last week. And the class form just keeps adding up. We'll probably have to make a cutoff eventually, but we're trying to get as many people signed up for the course as we can. That being said, your first, or I guess I can get into some announcements. It's Monday. There's my Dwight. First homework will drop on Wednesday. That'll drop like right when lecture starts or right after lecture, and you'll have all the way until next Wednesday's lecture, or the Wednesday after this coming Wednesday. So a homework will drop in 2 days, be due in 9 days. And it'll be due right before lecture starts. It'll be due at the start of lecture. That homework is not supposed to be too challenging. It should be pretty straightforward. There might be like 1 or 2 questions here and there that it might be a little confusing, but it's meant to just get you warmed up and get into the speed of it, of how learning Python. And then after that, it'll kind of increase in difficulty, like homework 2 and 3. They'll get a little bit more challenging than the first one. But so my reason for saying that is a lot of people see the first homework assignment. They're like, oh, this class isn't going to be that hard. This class isn't going to do it's not going to be a problem for me at all in any way, shape, or form. I don't have to take it seriously. Then homework 2 comes around. They waited until like an hour before the homework is due to start it. And then they're like, oh shit, I don't know what to do. So I'm just warning you, the next ones will be a little bit more challenging. Don't let that scare you. We'll have tons of support for you. Lots of office hours to go to. Lots of questions can be asked and answered on the piazza, and we're here to help you and get you through it in the easiest way possible. Reminders: we have a piazza. I kind of just said that. Anonymous place to post questions. It's linked on the B course's homepage. Highly encourage that you take advantage of it. And then attendance policy. This is still a little weird because we're trying to figure out exactly how to make this fair for everybody while taking into account the university's plans. Zoom only recorded lectures until we go back to in-person. Our plan is to try to keep recording those lectures for you, but we can't make promises. So because one, the Wi-Fi is awful in the lecture hall that we record. So that was an issue last semester as well. And sometimes Zoom, like we forget to record because we're only human. So we can't make a promise that every lecture will be recorded for you. So if you have a time conflict where you need to miss like 1 a week or 2 a week, it is doable to take the class in the sense that you can always look at the slides and whatnot but we want to take attendance so that you're paying attention to what we're teaching you and not just coasting through the class. So that means looking through the material, whether that be recorded, slides, and filling out a form to show that you did. So it is possible to not be able to attend every lecture, but we strongly encourage that you come to them if you can, just because it's better for you, it's better for us, it's better for everybody to feel more like a class. And you'll get more out of the lectures if you actually come to them rather than watch them at double speed or just look through the slides. Okay, so that's the attendance policy. We will start taking attendance when we go back to in-person. These first 2 weeks are going to be only Zoom recorded lectures, and we will try our best to keep recording lectures for you throughout the semester, but we can't make promises that every single one of them will be. Is there any questions about that? Okay, if not, I just want to remind everybody, it's not required, but we greatly appreciate it if you could turn your camera on. Makes it feel more like a real classroom. We see some of you have your cameras on. It's great, greatly appreciate it. It's not required though, so if you do, just it's just as a courtesy thing to help us feel more confident when we're teaching. See your reactions to things. Hopefully you're paying attention and all that good stuff. If you have questions, go ahead and leave them in the chat, and I will try to look at them, or you could just speak out. But I ask, if I'm in the middle of a sentence, try to wait till I finish. Find a good, you're all adults. You know how to ask questions properly. Anyway, let's get into a little bit more announcements. We have an office hour poll. So this is a QR code. So I hope everybody here is on the internet. That you should be on the internet if you're on this call. So you could just take your phone and take your camera. All you have to do is just open up the camera and point at your screen right now on this QR code, and it'll take you to this link, so you don't have to type it in. And this, everybody should just take like, a couple seconds right now, maybe like, I'll give everybody like 30 seconds to fill out your availability when you could go to an office hour. I put times from like 9 to 6 p.m. Monday through Friday. No weekends, unfortunately. We don't like hosting office hours over the weekend. We like to have our lives on the weekends. But let us know what office hours work best for you, and we will try to have office hours that every person can go to, at least one of them a week. Each office hour will be hosted by a different instructor. So myself, Megan, Emily, Isla, Raphael. Those will be hosted by us, and they'll be accompanied by one of the interns. Most of them will, at least. So that way we can help you, and they can learn to help you. It'll be great and all that good stuff. So I'll wait probably like 15 more seconds while people are filling out their availability. Yeah, I'll do a little dramatic pause for effect. Okay. Hopefully that was some time. If not, you can always just come back to it after the end of the lecture, but try to get this done before the end of the day. Definitely before the end of next lecture, because we need to get these office hours set up for you so that you can have them when you start your first homework assignment. So definitely try to get those done ASAP. Advanced topics poll. This is another one. So pull out your phone again, and another QR code. This one is like a multiple choice of like 6 questions. It should take you like 10 seconds. You're just telling us which ones you find interesting. There's like 6 options. This will come in handy for us later down the line. You're actually taking part of what this course will be like in a few weeks from now, maybe like week 8 or 9. We'll start introducing fun topics. So some of the topics on there is like machine learning, how to get a computer to learn and predict stuff based off of its observations. That's pretty cool. Used in like, I don't know, Tesla, like self-driving cars and stuff. That's like a nice little introduction to it. And then also there's things like animation, how to make, or how to do career development, how to like improve your status, or like how you carry yourself in academia, whether that be like writing a CV or making a personal website. There's a whole bunch of other things in there. But just lets us tailor this class to the interests of the people. So hopefully y'all have had enough time to just fill that out really quickly. If one of my instructors could also copy that. Okay, perfect. Thank you, Isla. And so today we'll get into the basics. This is super basic stuff. This is, in fact, we're not even going to talk about Python until halfway through the lecture today, because we need to first figure out how to navigate our computer without using a mouse. That might be a little daunting, but it's okay. I'll walk you through it. So the basics of how to code. First, in order to get into the basics, we need to understand what the command line is. So the command line might look like this or this. It's kind of that familiar like hacker aesthetic that you typically see in movies. It might look like this. It might even look like that. Maybe not. Wake up, Neo, if any of you are Matrix fans. But it's always that like kind of like white green text on a black background. Sometimes it's inverted, but in movies they always make it look like this. And it's like makes you feel like you're such a hacker when you know what this is and how to use it. So we're going to talk about it a little bit. The command line is just well, we need to talk about, or we need to understand it before we can actually code, because Python, or in order to use Python, specifically how to operate with files in conjunction with Python, which makes it really valuable in context of data, we need to know how to find our files in the computer in the first place without using a mouse. How do I just reference a file by text? That is a very important skill. So the command lines are different in Mac and Windows or Linux, but the general ideas are still the same. So specifically Mac and Linux are almost exactly the same, but Windows is different because, I don't know, Bill Gates and whoever else founded their operating systems decided they wanted to be cool kids and do it completely differently than the rest of the world. So every command is like different, doesn't make sense. I personally despise Windows because of it. But it's okay if you're on a Windows computer, we got you covered. You can still code and everything just fine. Here are some commands. So this is like a bunch of stuff. Normally, I would expect that I thought it had like, I thought that I made it like so that it goes bullet points, but it's fine. We'll walk through it. I have, my laptop is like, there we go. It's just in the way, but I think that works now. So I have my laser pointer here. We'll walk through line by line by line, and these are all the things that we need to know, all the commands that we need to know when using the command line to navigate our computer. So this will work by pulling up that terminal that looked like what we saw before. It'll be like blank and empty, and you could type into it. And so all of your computer is kind of, all the information on your computer is stored in what we call directories. This is the same thing as a folder on your desktop. Whenever you make a folder on your desktop, that's another word for that is a directory. Directories hold other directories inside of them, like a tree almost. They hold files in them. They hold whatever you need to store in them on your computer, whatever data that might be. So navigating between the directories is important. So if you want to find what current directory you're in or what folder you're in on your computer, you need this statement right here, this little command. So on Mac are all the left side of the slash, and then or like on the left side, and then right is the Windows version. So on Mac, PWD stands for print working directory, and all that does is it just tells you what directory you're in. I'll give you an example when I go onto my terminal and do a demo. See, the equivalent is CD in Windows, and you can already see why I don't like Windows, because in Mac, the next command is going into a certain directory we want to learn. If I want to go into a folder from where if like I have like I'm on my desktop and I want to go into a folder on my desktop from the command line, what do I type? Well, I'm going to need the command CD, which stands for change directory. I don't know why Windows decided to make it CD for theirs to say that's the directory you're in, but on Mac, CD stands for change directory, and this is the same for Linux as well. And then you just put the name of your the file path. So it'll make more sense when I actually do it on my terminal as a demo. So just hold tight. If you want to list what files are in your directory, you could do ls. I don't really know what ls stands for. dir is the equivalent in Windows, but if you type this command in, it'll just print all of the files that are inside of a folder, basically, that you're in. Then creating a directory, if I want to make a new folder, it's pretty makes sense. This command is mkdir, short for make directory or make dir. And then you just type in, you write the name that you want for your folder or your directory. If you want to move a file into that directory, you do move mv or comma move or like on, it's the actual word move on Windows, but mv is short for on Mac. And then you have the original path of the file that you want to move it to or move from. So if you have a file on your desktop, you would put the file pathway right here, and then you put the pathway that you want to move it to, and it'll make sense when I do a demo. I promise it'll make a lot more sense when I actually do it. And if you want to rename a file, you just move it to a new name. So like you write the name of the original file and you move it to a new name. It's a weird way to do it, but it's whatever. I guess it's to prevent you from accidentally using RM. If you did RN for rename, that would be very easy to mess up with RM. And if you RM something, that's deleting a file, also known as del on the Windows. Now, if I RM and then a file name, it'll delete it. And this won't just move it to trash. I'm talking like delete it from the computer. So be very, very careful when you use the RM command, the deleting command on the terminal, because if you do RM desktop, your desktop will be removed from your computer. Like you won't have a desktop anymore, and you'll have to reboot the whole operating system and like reinstall everything. So don't do that. That's happened to a friend of mine. Is very bad when you remove the entire desktop or remove like your entire documents folder or something. You definitely don't want to do that. So just be very, very careful and make sure it's the file you want to remove before you remove it, or just drag it into the trash can on your own. So you better take a screenshot now, or save this. You might want to just like save this somehow, get these commands like engraved into your brain, because you're going to use them anytime you open up a terminal. And I'm going to give you some demonstrations right now. Cool. It looks like my instructors are taking care of questions in the chat. Love to see it. I'm going to do this. Can everybody see this desktop? So the way you open up a new terminal, at least on Mac, it's called terminal, and you can just do a little like command space bar and then type in terminal to find it, or however you search your computer. On a Windows, I won't have it here because I'm on a Mac, but on Windows it's called command prompt. This is the same thing, but on Mac that doesn't exist. So terminal is what we'll use on a Mac, and it's the same on Linux as well, terminal. So anyway, we'll open up a terminal, and whoa, hold on. Opened up in the wrong thing. Can everybody see this black screen? Now it looks a little different because I have emojis, but don't worry, that's just because I took the time to figure out how to do that. Normally it just has like some white text and it looks pretty bland and basic, but I wanted to spice it up. So let's just play around with some commands really quick that we learned. So pwd, right now I have no idea what directory I'm in when I open this up. So I want to know what directory I'm in. So if I print working directory, it says that there's a users folder, and then inside of that users folder, there's a folder called James Sinceri. This is like my account. So if I want to see what folders are in this James Sinceri folder on my computer, all I have to do is type ls, and it shows me all the folders that are available. Now on your computer, it probably won't be green for folders, but I changed it to mine. It should just be white, but you'll recognize based on name which ones are folders. Like here's my desktop folder, here's my downloads folder, music, movies, simulate, blah, 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 bunch of other folders. But let's say I want to go onto my desktop folder. So all I have to do is cd, which stands for change directory, and then I can just do write the word desktop. And this will cd or change directory into this desktop folder that I want to access. Cool. So now you'll notice that this little green bit changed. This was actually printing the directory. I'm on like a squiggle. I don't know why it's not important why it's a squiggle, but now it's desktop. So now I'm in my desktop folder. That's the name of the directory I'm in. So now if I ls, we'll see, oh, my desktop is really messy. But I have folders on my desktop. Some of these are probably pretty familiar in the sense that like I have like an artwork folder, I have like a school stuff folder, Python decal. And if you want to see exactly what that would look like with like just with a mouse and keyboard, it looks like this. Can everybody see this screen with my mouse on it? Yeah. So as you can see, you know, school stuff folder, I got like an artwork folder. It's all here, but now I'm just using a terminal to view it. And the reason for that, or the reason why, is because whenever you're coding, typically you can't use a mouse on like servers and stuff. Whenever you're interfacing with other computers, you might not have the option to use your mouse. So knowing how to navigate a computer without a mouse is important. So now that I'm here, I saw what's in my desktop. I can go into another folder if I wanted to. Let's say, I don't know, we could do, we can go into like my Python decal folder. And now if I look what's inside of there, you'll see I have a bunch of resources from from teaching this course, for example, in here. Now, if I want to go back, like a folder up out of and like leave this folder and go back to the desktop, you might be wondering, okay, how do I do that? Well, there's a couple ways to do it. I could write it out from scratch. If we figure out what directory we're in, right? It says users /James Sinceri / desktop and then Python decal. I could do CD and then just copy this entire string right here and go into it that way. But a shorter way to do it is if I only want to go one folder up, I could just do a double dot. And this is short for go back one, go up a folder. Like, yeah, basically the back button in your file management. And now we're here. If I wanted to move a file, like, I don't know, maybe I want to move final.move, like a movie file, and I want to move this into the Python decal folder. I could do move final.move. This is the name of the file. And then I can move it into a directory. Let's say Python decal. And like I have like a little / here to say I want it to go into the Python decal folder. So now it's going to move this movie file into this folder. And if I go into the Python decal folder after doing that, and I press LS to view what's inside, you'll see, boom, it got moved there. So now it's inside of that folder. And similarly, I can move it out with the double dot and using the same command. If I wanted to, I could RM. I could remove that file. I'm not going to do it because I want that file, but I will move it back. So I can move the final.movie file back of a directory with the double dots. And now if I go back a directory back onto my desktop, you'll see it got moved right there again. So this is just a very basic, quick crash course on how to do this. Yeah, is there any questions? I kind of went fast through that because I got a lot of other stuff I want to talk about, but is there any questions? Yeah, it's a lot. Don't worry. All of it is basically encapsulated on that slide I was showing earlier. So, oh crap. I didn't do that. So if we go back to the slides, all of that information I just said is on this slide. So you can just, it's really just sitting down, having this like by your side, and then going on a terminal and playing with it, like for a couple like minutes until you feel comfortable with it. It feels it's much easier to learn when you actually do it yourself. So I encourage you to have screenshot this after this lecture and play around with it yourself. And it'll feel a lot more comfortable. But that's like the basics of how to use a command line. There's other things you can do in it. In fact, you basically use your entire computer how you normally would from the command line if you really, really wanted to. There's 1,000 commands that you can learn, but these are the crash course ones. These are the ones that if you took a class on Unix or something, or command line stuff, this would be like, you know, the first few weeks of it. This is your cheat sheet right here. Very, very useful stuff. And there's a lot of other things you could do, but we won't get into that. Cool. Somebody left a nice link in the chat as like a resource to learn some commands with practice. So I encourage you to do that. If there's no questions, then I'm going to move on to Python. So now we can actually, now that we know what a command line is, and we know there is a way to navigate my computer without using the mouse, just only with only a keyboard and text. Now I have a lot more power when I go to use learn a language, because now I can interact with my computer. I know how to store, like I know that a file is going to be in a directory. So if I want to pull that file from a different directory into my script or whatever, I know that there's a possibility of doing that now, and I'm not just completely clueless. It might take a bit of practice to learn how to do that, but we'll get there eventually. We need to cover the basics though. So you might be asking, what is Python? If you've never seen it before, some of you come from really high coding backgrounds, and in the sense that you've done a lot of other languages and stuff, and you just don't know Python that well. And some of you literally have never touched like the command prompt before, or the terminal, never coded anything before. That's totally okay. We're meant to cover the basics and build up. So you're in the right place if you don't know what Python is. Python, to answer your question, is an interpretive programming language. All I mean by that is just that the computer interprets the text that you put in and converts it into instructions for the computer to execute. That's all. So you're doing the thinking for the computer. The computer is just trying to understand what you're saying and do what you're telling it to do. There are other programming languages that are more declarative, in the sense that you tell it what you want and it'll do all the work to figure out how to do that. You don't have to tell it how to think, but it will get you the results you want. That's different. This is, you're expressing your ideas into a language very similar to a foreign language that you might not know, like French or something. You learn that language, you learn the syntax, you learn the rules, the grammar, the vocabulary, and then those are tools in your toolbox to communicate ideas. And it's up to you to think of those ideas and express them. Same idea with Python, except now we're communicating with a computer to tell the computer what we want it to do. So this Python is a really nice language. It's a great introduction. It's used across the globe in like so many different fields: astronomy, physics, chemistry, data science, machine learning. It's everywhere. It's incredibly valuable, and it's a great first language because it's high level. By high level, I just mean it's easy for you to read, and it's like in the sense that it kind of reads like English. So if you know how to read English, I think it'll be a lot easier to read Python than some other languages you might have heard, like C++, or Fortran. Don't even get me started on that awful language. Like in general, like a good rule of thumb, the more unreadable to you the language is, the faster it runs, but the harder it is to learn. So readability is typically associated with like the amount of levels above like the main, like, you know, ones and zeros in the computer hardware that's like switching electrical pulses into and converting that into binary. That's like the very basics of the computer that you are so far as a user removed from. We're like way up here in terms of like levels of abstraction. But the lower you go, the more hard it is to learn the language, I guess you would say. There's more things you have to be very explicit about telling the computer, like where to store the memory on your chip and all that stuff. For us, we don't have to worry about any of that. All we have to worry about is just expressing our ideas and writing it down. That's basically all we have to worry about. So that's what Python is. It's a programming language that we can express our ideas, and it's very commonly used in the scientific communities and STEM fields, but elsewhere too, totally elsewhere. It's awesome. You can do a lot with it. In fact, just a fun piece of information, all those emails that you got about like entering the course with your permission codes and like the announcements and stuff, I sent those with Python. I did everything with Python because I was too lazy to send 70 emails by myself. So I had a Python script do it. And you can figure out how to do that too with this class. So some of the basic features of Python, or most programming languages, or if not all, no, all programming languages basically, is that they can serve as a calculator. They're like the most advanced calculator you could possibly ever imagine. What do I mean by that? I mean you should be able to take, some numbers, or for example, and operate on them. So basic PEMDAS stuff that you might have learned in high school, right? Parentheses, explanation, or parentheses, exponents, multiplication, division, addition, subtraction. It's like, it should be able to do that at the very least. So if I wanted to write some Python, this is actually like a little bit of Python. We could break this like whole expression, like this entire expression, into bite-sized chunks. And then what I mean by that is we can focus on the values and the operators. So the values are like the actual numbers. These are like pieces of data that we can put in ourselves, like just numbers. So 343 and then 34, 59, blah, blah, blah. And the operators take those numbers and they combine them in a way that does an operation. So addition is an operation in math, right? So 343 plus 34. Now it doesn't read it exactly in that order because we follow the rules of PEMDAS from your high school or from algebra, whatever, your upbringing. If you learn math, you probably know this. But we do multiplication before we do addition, and we do division before we do subtraction. So this little asterisk, like star symbol, is what we use for multiplication in Python. And then this like single slash is what we use for division. So this is addition, multiplication, subtraction, and division I have written here. And if I wrote this in my computer, in my Python terminal, or like in my Python, and I run it, it would give me whatever this value is. I don't really know what the final result is of this entire operation, but it should give me that. It should at least operate as a very basic computer. Now, what makes a language or what makes it so powerful is that we can take a variable and stick it into an expression and use that variable to however we want. And we can stuff things inside of variables, and we can take them out, and we can encode all the information that we want into variables and move them around and do operations on them. So now if I have a variable X and I stick it in there to multiply to 34, and then it spits out some value, well, now it's almost like a function, or it is a function, right? I can write a function that takes in a value X and spits out whatever X is when you put it in this entire expression. And that's what makes programming useful. What makes this such a powerful calculator. You can use variables to your advantage in whatever you really want. And we'll get more into the details of how to do that. But you might be wondering, okay, so what is a variable? So a variable is just a way of storing information in the computer. We typically call this information data. And data can have several different types. There's different data types is what we call them. So these different types, like typically when you write some Python, it'll look like this, where you have like, I'm setting like a variable X is equal to 7, where the left side of the equal sign is the variable name, and the right side is like its corresponding value. So this is like the data. So 7 goes in is equal to X. Y might be equal to some name, some string, or like some information of text. Maybe Z is equal to a list of values. These are me setting variable names equal to pieces of data that are different types. And we'll go through the different data types right now. So what are the different data types? Well, there's mainly 6 basic ones, but we'll see that that's kind of a lie. There is more stuff that you could learn how to use, but these are the basics. These are like what comes straight in Python and most other languages as well. Very similar to this, but these are the basics, and you need to know these before you go in anywhere else in coding. So they're like, the data types can be broken down into integers, which is basically whole numbers, floats, which is decimal numbers, or numbers with decimals, strings, which is like characters that you would type, like the alphabet, and like sentences and words and stuff. Then there's lists, which contain several different pieces of data. So maybe I have like a 7 and like a 7.3. So I have like an integer and a float, and then I have another and another and more information. I can contain lots of information in a list of values, just like a normal list would be if I had a list of anything. Tuples are like the same as lists, but a little different. We'll get to that. And then dictionaries, also very similar to lists, but a little different. We'll get into that. Any questions right now? Okay. If not, then we'll move on. So now we might want to ask the question, how do variables or data types or different ones interact with each other? So how do different data types and variables interact? We'll talk about numbers first, because I think that's the most straightforward one to think about. So like I said, there's integers and floats. Now what I have here, like blue is like just saying what they are, and then yellow, basically my kind of so you can walk through my coloring. Yellow usually means like pieces of code that you could just put into Python, and then like everything else is basically just either like light blue is typically highlighting for you to look at, and then gray is not important, or kind of important, but you don't need to focus on it too much. So here are some examples of integers: -3, 2, blah, 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 all the way to 3, and then floats. So integers, no decimal; floats, decimal. You might want to check to see if like an object has a specific type. So if you want to do that, it's really simple. You just type the word type and then parentheses around whatever object you want to put in there. So if I have the number -3, I could just put that inside of these parentheses, and it will tell me that it's an integer, not a float, because there's no decimal. So here's a question for you. Anybody, maybe you want to type in the chat or speak out loud. What is the type of this really big number? Yeah, okay, great. Thank you for the chat. Float, yeah, it's a float. And the reason for that is that there's a decimal. Nice and easy, pretty straightforward. You can operate, you do operator, or you can combine these with operators to do calculations. So plus is for addition, like I said, minus is for subtraction. This little star, asterisk, that's like shift 8 on most people's computers. That's multiplication. The single slash means division, just like straight division. So if I have like 30 divided by 5, that'll give you 6. This little percent sign is code for modulus. So that's the same thing as a remainder. So 10 modulo 4 has a remainder of 2, because 4 goes into 10 twice. So you have 2 left over. The double slash is the quotient. So if I want the quotient, not the remainder, I just do that. So 18 quotient 5 gives you 3. And then 2 stars next to each other is for exponents, not a caret. Caret is something completely different in Python. So do not use a caret when you want to do exponents. No matter how tempting it sounds, don't do it. 2 stars is exponentiation. Okay. So now we'll talk about characters and words. So strings, we call anytime you have text in anything, that's a string usually. And the way we know it's a string is it's encapsulated inside of quotation marks. Now you can use single or double quotation marks. It's completely up to you, but you have to stay consistent. Meaning if I start a string with a single, I have to end it with a single. If I have a single and a double, it'll be confusing, not know what you're talking about. So if you have doubles, you got to end with doubles. And if you start with singles, you got to end with singles. So just stay consistent. And so if you want to put like quotation marks inside of something, so if I want to say like, and the child said, you know, like a quote, I would want to make sure that my quote has double quotation marks, like the whole thing on the outside, and then single quotes on the inside, if that makes sense. So, but that's not super important. We can talk about that later. You can add strings together. So you might think, what? Add letters together, add them together. How does that even work? Well, they don't add like normal numbers. So 134 in string form plus 34 in string form, it just adds them right after each other. So 134 34. That's what happens when you add strings together. So if I have the string hello and then the string world, it will, if I add them together, it'll be hello world. It combines them like that. Whereas if these were, you know, integers, that's what their data type was, then they would just add like normal numbers. But in this case, they're strings. And we know they're strings because of the quotation marks. Indexing. So if I want to pull out a specific letter out of an entire word or text string, all I have to do is whatever my string is, I can actually index it with these square brackets. So if I want to pull out the H of this entire expression, hello world, or this entire string, all I would have to do is do square bracket, 0, square bracket. And we index anything in Python starting with the number 0. This is very not natural for people that don't code, but if you've coded before, you're pretty familiar with the indexing at 0. Everything starts with the number 0. So if I want the first thing in the sentence, H, I need to use a 0. If I want E, I use a 1. If I want L, I'll use a 2, and so on. So an example of this, hello world, if I type this in, if I have the 5, well, I can count 0, 1, 2, 3, 4. 5 is actually the space. Space counts, like the space bar counts as a character. So that is the 5th index. Okay. So you can index strings with this square bracket notation. You can pull out whatever letter you want. Cool. And it doesn't just have to be letters, it could be numbers, it could be anything as long as it's inside of the quotation marks. So here's a question for the chat. What is the output of 7 times 1? Anybody have a guess? Like 1 in string form. Good. Yeah, a couple people in the chat got it right. Yeah, it's 7 ones all next to each other. So we're just, it'd be the same as doing 1 plus 1 plus 1 plus 1 in string form. That's just 7 ones next to each other. So you can multiply sentences together or whatever to repeat yourself or whatever that might be. Cool. So now we're moving into lists, tuples, and dictionaries. And the reason I have all these together is because they're basically the same thing with slight differences. Specifically, lists and tuples are like almost identical. So what is a list? A list is denoted by these square brackets when you're creating it. And it just contains, it's pretty, makes sense, a list of values. So for example, this list has the number 4, number 9, a float of 7.5, the word astronomy in it. And then it also contains another list inside of it, which has its own things. Don't worry about what this true is, we'll get there in a second. But nonetheless, a list contains, anything inside of it that you want. But they're all separated by commas. So, I better be moving quickly. You can index these the same as strings. So indexing with a 0 gives us the number 1. You could treat every one of these like a letter or a character in a string, except a list is just separated by commas. You can like a -1 pulls from the back of the list. So -1 gives you the number 6. And similarly, -2 would give you the number 5. You can also index by like slicing. So 2:5 says I want everything from 2 of the second index to the third, 4, or my bad. This is the second index, 0, 1, 2. So I want everything from 3, 4, and 5 because this is the second index, third index, fourth index, but we don't include the 5th index, number 6. So contains the starting index and doesn't contain the ending index. Yes, lists are separated by commas. Everything inside of a list needs to be separated by a comma. You can modify the elements inside of a list. So if I want to say, if I have some list equal to 1, 2, 3, my list, I could set the 0th index in that list, aka this number 1, equal to 37. And now if I go to see what my list is again, the 37 is replaced, or the 1 is replaced by 37. Similarly, you could do operations. So 3 times 1, 2 in this list would do 1, 2, 1, 2, 1, 2. 1, 2 plus 1, 2, 3 is 1, 2, 1, 2, 3. They add just like lists or like strings do, and multiply just like strings do as well. You have to separate them by commas. You cannot separate them by spaces. Yeah, cool. I'm going to keep moving because I realize I'm a little short on time. Tuples, exactly the same as a list, except instead of square brackets, we use curly brackets, or not curly, like parentheses. And the reason for this is to differentiate or to show the difference, or what the difference is that these can't, you can't change what's inside of them. They're called immutable. So you can't change the elements after you make it. So if I have this tuple and I index it, and I do some index where I say like I'm indexing this list inside of this tuple, I can't change this value inside the tuple. Python will get mad at me. I'm going to skip a little bit through that. Don't worry about what's going to happen there. A dictionary is very similar to a list in the sense that it's you can index it just like a list, but it has keys and values. I'm going to come back to dictionaries a little bit later. We'll talk about them when I have more time because I want to make sure I finish today's lecture. So we're going to skip through some of this and we'll talk about it next time. We'll in like our warm-ups. There's booleans. So booleans is like true or falses. The way you know if something is a true or a false. Anything in Python can be represented as a boolean if you convert it to a boolean, but knowing what something will convert to is a little tricky. Everything is considered true unless it's not. And so it's easy to remember what's not true. Zeros, empty lists, empty tuples, empty dictionaries, empty strings. The word none, it's not informed what that is yet. All of these will be false. Anything where if there's any characters inside of it and basically any information other than zero or empty, it's going to be a true value. So yeah, that's really all you need to know about booleans. So that can somebody try to answer what this might be? The boolean of a string of a space. I only got two answers. Yeah, there we go. Yeah, so it's true because space counts as a character. So it's a little tricky for your brain, but if there was no space, then it would be false. And you can do operations. We'll talk more about that when we get into conditional, so don't worry about that. Okay, yeah, I have 2 minutes left. I think I'm back on track. So variables, we give them names. The way we assign a variable is with an equal sign. So x equals 1 is setting this name x in like Python equal to 1. It's like assigning a variable, just like in math. Similarly, y equals 2. And then when I use x and y like numbers, x plus y should give me 3 because I set x equal to 1, y equal to 2. I want to give you some like naming advice. When you name variables, you cannot start with a number for a variable name. So I can't make a variable name 1. Like you can't do that because 1's already a number. Don't start names with 0 or O or 1 or I typically, unless it's like an actual word. You could put an O, but don't start with 0 or 1. And try to avoid starting with an I, in my opinion. Make your variable name immediately clear and recognizable. Here's like a little information. And I really mean immediately clear and recognizable. If you don't name them clearly, this is us. When we read it, it's very hard to understand what the hell you're talking about. So if you have a function or if you have some Python code and you have a variable that represents temperature and you call it A, how the fuck am I supposed to know what that means? Don't do that. Keep them concise and don't write entire paragraphs for your variable names, but make them readable. Like if you're trying to use like a function or some code or variable name to calculate something, it should be clear what you're trying to use it for. It helps us grade your homework. It helps you understand it when you go back to show somebody else your code. Make sense? Clear, concise, and recognizable names that represent what you want them to. How do we use variables and data types? There are many ways. Computers are really good at handling data. We'll get into that next time a little bit more, but it's our job to tell, it's all it is our job is, or our job as programmers is to tell it what we want to do with the data. The computer is what I mean by it. On Wednesday, we'll get a taste of it with functions, and that'll give us a real taste of power when we get into coding. How do I start coding? I realize it's 4 o'clock. I don't really have time for this demo. I was going to go through Jupyter Notebooks, but we'll talk about that when we start next on the lecture on Wednesday. Sorry for rushing through that. I realized I was going a little slow. I'll pick up whatever I missed next lecture with a little bit of time. So I'll carve out some time to make sure we're good on that front. But so don't worry if I went too fast. It's also recorded, so you can go back and look at it, and we'll post the lecture slides so you can take a look at those as well when you want to. Sorry for going a little bit over. I hope to see everybody on Wednesday. And yeah, you're free to go.
James, I have a question.
Yeah, what's up? Here, I'll stop recording.
Is the difference between tuples and list that tuples have to be all the same data type where lists can be different data types, or is that not it?
I don't, yeah,
I
so
sorry, I put this in the chat earlier. I think you asked it in the chat or someone else did. But like for tuples and lists, you can have different data types in it, but a list you can add stuff to the end of. So for example, you start with a list with like 3 elements or whatever, you can add more elements to it. You can make it longer, you can remove stuff, whatever. But if it's a tuple, if you make one with 4 elements, it stays 4 elements. Those 4 elements can be whatever. They can be strings, floats, ints, whatever. And you can mix them, but like you can't extend a tuple's length or
Got
like
it.
change it. Yeah.
Got it. Okay, great. Thanks.
any other questions?
Yeah, when I like open the terminal thing,